What's up, everybody? It's your boy Jester James here, coming at you with another YouTube video. In today's video, I'm going to be continuing our work on the case of the stolen Szechuan sauce, and in the previous video, we were working on the disk image. So if you remember, we were using tools like Autopsy and FDK to really go and plug into the image, extract some artifacts, taking a look there, and we went to go and answer some of our questions to answer from our sheet here, such as operating systems, was there a breach, what's the local time of the server, and from the disk image, we answered some of these questions, but there's also some questions here that we weren't able to answer that we're going to be able to answer further or have some more context for these answers based off of what we're going to get from the memory image. Encourage you all to be taking notes, marking notable timestamps, because that is a key component to performing your analysis and also being able to explain what you've done. But enough of that, let's get straight into it. Let's get started with some memory forensics. First off the bat, you're going to want to do is download Volatility. So Volatility is an open source project licensed under the GPL 2.0, and it's basically the #1 memory forensics tool that we use, and you can download it from volatilityfoundation.org. Just navigate to the website, go to downloads, and download your respective installer. For us Windows folks, we're going to be just using this Windows standalone executable, and you can use Volatility 2 or 3. I'm going to be using Volatility 2 just because I know Volatility 3 has some updates there, and I just don't want to be kind of fiddling with Volatility 3 just yet, because I know there are some kinks into the install there for my OS that I'm using right now. But Volatility 2.6 does the job well, and download it, have it set up. Once you download it, you can unzip it, and for me, it's just in my tools folder. So right here, you can go to Volatility, and this is what you have in the folder, and this executable right here, that's the tool that you're going to want to use. So it is a command line tool. I know y'all in previous videos we've been really doing some GUI. We've had some user interfaces that we can use, but we're going to be using the command line for our memory forensics here. And let's just get straight into it. So if you haven't already downloaded that memory image from the site, you can go and do it here, DCL1 memory. And there's also a desktop memory image, but after going into the DC, so I'll be looking at the DC's memory first, and the process is pretty much the same for the desktop as well, but our focus for this video is going to be looking at that domain controller, and I'm going to let you all go and work on the desktop yourselves. But spoiler alert, this will have the answers for the case and also for what we're looking at on the DC, and it basically kind of matches up with the desktop as well. But the desktop analysis, y'all can do that on your own, just based off of how you'll be using Volatility here. And let's get straight into it. So right off the bat, let's take a look at Volatility as well. I'm just going to scroll down a little bit here before I pop it open. So we're going to go to, let's go here, because that's where our data is. Well, actually, you're going to want to now, let's go to where Volatility actually is, so then we can execute it. CD. Alright, so we got Volatility there, and if you do run the -H, it'll show you basically the same thing that's on this documentation page behind here. But it gives us a list of all the different plugins that you can use in Volatility and extract different artifacts and see what you can look at there. And I'm not going to go into all of these, but there's a couple of them that are key that we'll be using, but also are good for reference. So there's like connections, there's ConScan, there's DLL list, DLL dump, where you can dump DLLs. There's event logs. There's LSA dump. A lot of really good tools. PS list, PS scan. So those are more for processes, and those are the ones that we'll be using mainly. There's strings in there as well, so you can use strings. And as it says, yeah, very verbose, may take a while. And that matches physical offsets to virtual addresses. So a lot of these are artifact specific. But so right off the bat, when you're using volatility, the command line syntax goes like this. So you specify the executable and then specify the plugin. So the first plugin that we're going to be using is called image info. And you have to use that in order for volatility to kind of scan that memory image to actually understand what it's looking at. And also, if you don't know the operating system, you're not going to be able to have volatility parse through the image and understand what it's looking at. So we actually have to build a profile on this image, and thankfully we already know what the operating system is, but I'm just going to be running image info just so you all can take a look and see what exactly that looks like. It's not being... Alright, so -F is to specify the file, and I've specified the file citadel dco1.mem because that's going to be the main memory image we're going to be looking at for the video. So right now it's performing what's called a KDBG search, and basically that searches the bytes of the memory image for known signatures or of the operating systems in the kernel debugger block. So KDBG stands for kernel debugger block, and right now it's just scanning based off of all the different signatures it has. So it can be Windows 8, it could be Windows 10, Windows 2012, R2. That's the operating system, but where I'm jumping ahead here. So letting volatility do its thing. Alright, so we got image info output. So the suggested profiles that we have here are Windows 8, and then we have Windows 2012 R2, so Windows 2012 R2. So there we go. So it's just Windows 8 first, but it does get there. So the profile we're going to actually be using is Windows 2012 R2 x64. If you want to test out running it on these Windows 8 profiles, you can do that, but I think it'll... So sometimes if the profile matches up a little bit, you will get output that is legible, but then you will also have output that is not legible. But in our case, we do know what the profile should be, and Volatility has a bunch of useful plugins that you can use and play around with to get some great information and evidence of what's going on. But let's start with a list of the processes that were running when the image was taken. So also preface real quick, if you need to take then a memory image, how to create a memory image to begin with, you can use FDK to do that as well. So FDK, if you just go to File, hit Capture Memory, here's your destination, where do you want that file to go, and then name it, and then you can include you can include the page file as well, and you can also create an 81 file. I don't remember what the 81 file is off the top of my head, but the page file includes a lot of relevant artifacts as well for the OS specifically. I do know that in here we do have the page file too. So the DC01 does have the page file. Yeah, there it is. So Volatility right off the bat, continuing on with the syntax, basically it's the same here. We're just going to include the profile now. So the next plugin that we want to use in order to list those running processes is called PS list. So first what I want to do is I'm going to specify the profile. So that's -- profile equals Win 2012 R2 x64. And then the next plugin is PS list. And then we specify the file. Hasn't changed. Volatility is running, and now you see it also tells us this. It gives us a little bit of a nice little table to detail that. There we go. So here we already can see things, and in our previous video, one of the things that we were able to identify sus was that, what was it? Core updater.exe. So you can see that here, right here, and it's the only, it kind of stands out in itself. However, there's also more evil here. There's some more here that you're gonna have to dig into the memory to actually identify. So now going through this, we can see some processes that are familiar, but nothing is really standing out in a massive sense. But if you want, you can do a reputation check on all these processes to see if any of them are sus or if most of them are standard for a Windows system. But I want to take us a step further in our memory analysis here by taking a look at the network connections that were active as running. This next plugin is going to give us the processes as well as the IP addresses for the connections they make and whether or not they are established or closed. So when the process is doing some network activity, we have the plugin to be able to identify that as well. And that plugin is going to be called NetScan. But so furthering in our memory forensics journey, just change that from PS list to NetScan. That's going to give us another process list, but again, it's just going to give us some network data with it as well. And as you see, this is really, really big. There is a lot of activity here. There's a lot of DNS there. Some LSAS is going to be showing up as well. And you see, there's a lot. And by a lot, I mean a lot. You saw how much that was. And a majority of it is DNS and LSAS, as you can see, which makes sense because this is a domain controller. So for the system itself, what it's used for, this network activity, this much is kind of exactly what we expect to see. But you do have the txt file here, and I did clean it up. So I removed a lot of those DNS entries, and you can do that as well. You can do some command line foo and parse that out, and I'm going to leave that up to you as well because that is a critical component as well when you're going and doing some good old text wrangling in order to read your output. So I removed a lot of these duplicate DNSs and LSAS, and we can see some of our processes from the PS list before, and here we have local address, the foreign address, and whether or not it's an established, it's still open, so it's listening, or if it's a closed network connection. So I'm going to scroll down here. We can see, so there's some like IPv6 happening there. And let's see if we have anything that stands out. And there are some things, so like for y'all, when you see IP addresses and you want to identify, so obviously if it's private IP, then it's private IP, like this 1270, that's localhost. But when you have things like here, so you have like 10.42.85.10, it's like that IP is, I'm pretty sure that's the IP of the domain controller. Yeah, so that's the domain controller. So let's see, let's go back up. So we want a foreign address. Let's see what we have in foreign addresses. So like where's a destination that is a remote IP? So here's like this. So there's like 203. So this is a public IP, and there's core updater.exe. So like there you go. we had identified this by sheer luck by checking out the hash of that core updater file when we saw it in the disk image. But if you look at this here, so here's a foreign IP address. Let's copy that, and let's do some reputation check for the IP addresses. So there's a few tools that you can use. VirusTotal, just like you would rep check a file hash, you can rep check an IP address. So now that that's gone, so 203.168.103.109. So this IP itself is not being deemed malicious by here. However, this case is about a year old now. So allegedly, this IP was part of some C2 activity, and it would have gotten some flags. But this IP, basically, that's Thailand. I think TH, yes. And then, so there's another tool that I use quite often, and that is MaxMind GeoIP. And that, again, yeah, Thailand. So that makes sense. So this machine is located in the US. Why is it communicating with Thailand? Obviously suspicious. So we can mark that down. So right here, core updater.exe. Obviously, we know already that this is a malicious process, but this is furthermore supporting our hypothesis that core updater.exe is malware. And it's not a hypothesis because we proved it in the last video, but this shows us that in memory, it is also doing malicious activity by contacting this IP address. And from that, you know, that's coolio. But now that we have one malicious process, that's great, but there's more. So let's use a nifty volatility plugin called malfind. So obviously, there's a lot to look at in memory in itself. One of the a good plugin that really goes and searches all of the memory for malicious file signatures and also potential other malicious activity is malfind. And basically, I haven't gone into how this works enough for me to want to explain it in this video, but if you go into the volatility documentation, I'm sure it's in there. But it's very useful because it goes and details exactly what I'm going to show you right now. So you run that, and you get an output that looks like this. And what this is you can see this is assembly code, and we also have some hex here too. So there's the output. It just ran. I just output it to text file here. And so right here you can see hex. And for those of you who have watched any of the previous videos or aren't familiar, file signatures, you can identify some file signatures here as well. And we'll get into that a little bit more as we see it. However, scrolling down here, it doesn't make a lot of sense to me just because I also don't know assembly. I don't know assembly. I know a little bit of reverse engineering just to get by, but I don't know what this means. And from what I've been told, you should look for sandwiches, and if it's not in that sandwich pattern, then something's there. But scrolling down, so the create component is, for me when I was looking at this, was looking at the file signature, and that is looking at this hex component here. So scrolling down, scrolling down, scrolling down, nothing of use, nothing of use. And then we get to here. So this MZ right here, this is what keyed me into this process right here. So this process, spoolsv.exe. This process, MZ, that looks like code injection to me, process injection. So that's a hex header. MZ, that is for an executable. And if you haven't already looked at Gary Kessler's site, that's a great site in itself, but he has a file signatures table that I've used for a long time, and he basically has all the hex signatures with the file extensions. So if we go to MZ right here, so there you go. That's that 4D5A right here, MZ, and that is a Windows DOS executable file. which makes sense. So going forward as well, there's another one here. And these are on different offsets too that you can kind of look at there. So that's a different offset, that's a different offset. So it looks like there's two in that one process that's running. So that tells me it looks like there's an executable being injected into this spool sv.exe process. Now, the thing is, I know spool sv is a normal Windows process. So off the bat, this process, if you're looking at it from that process list view, right? So if we go back and we're looking at the process list, you can also do ps tree, which will give you the processes in a format that shows who the parent process is as well. But if you go and look at the process list, right, spool sv.exe, that process is legitimate. If you Google that, like I'm pretty sure that's for printer stuff. Yeah, so spool sv runs the Windows OS print spooler service. So it's for caching the print job into memory. So that makes sense. So like looking at this process list in itself, where is spool sv? Right here. So this by itself, right, if you're just looking at the process list, this does not stand out. However, by using malfind, we're able to go and see that there is some process injecting going on there. So, going forward, we've got our text file here where we're looking at it. Now, so this is now because of the fact that this spool sv process is a legitimate process, it's a great choice for the attacker to hide their evil under this seemingly normal Windows process. But going forward, there's more of that, and I can see we're looking at the same process here based off of the process ID 3724. But let's not stop there. So 3724, 3724. So there's those two MZs, right? We're matching those up. Yeah. Now we're gonna level this. We're gonna level this up, and what we're gonna do, we're gonna use another plugin now. So Volatility has told us to look into that spool sv process, and what we're gonna do is we're gonna use malfind again, but this time you're going to add -d, and you're gonna hit mal dump. We're gonna dump those processes. Yeah, you're going to have to create a directory. I'm just going to have it dumped to the Volatility directory itself, just because I know what's there. So now this is fun because Windows Defender is going to catch the process being dumped. There it is. Yeah, so you can see that. And we already know. There it is. Like Windows Defender does half of the work for us there. So we already know it's Meterpreter there. So Core Updater we knew was one piece of malicious code. But now in Spool SV, there's another piece of this malicious code here that we're getting from this dump. So it's quarantined right now. And there it is. It's that process right there. And there's two components too. So this is one piece of it that they've identified of quarantine in itself. But so Windows Defender has caught it, and I'm just going to remove it at this point just because I know that's sitting there, and I don't want to add any more firewall rules. But when I was looking at this firsthand, Windows Defender had caught it, and I did have to leave it in that folder. Where did it go? Right here. So these are the processes. It's processes that have gotten dumped. And among these, one of them, or Windows Defender had picked on one of them, but there's another one that showcases so these processes, you want to take a look at all of them basically, and you can look at them based off of the address that Malfind gave you to. Where, let me pull that up again. AFC26. BFB2. So you can see the processes getting dumped. So we have them here. And so now that you have these dumped processes, this is where you kind of start to do some more, we'll say, malware analysis on these processes. So obviously, you now have malware on your system by dumping these processes. So you want to be careful when you're looking at it, and also potentially you don't want to execute anything there as well. But they're all under the .dmp extension. And again, yeah, Windows Defender, right? It'll catch, and it will throw things out. So I'm gonna go back here. Yeah. But one of these processes, AFB, FB2. So this process specifically I already had looked at, and I know that is the one to pop open for the sake of the video. So one of the things you want to do is look into each of these dump files and identify which one would be of most use. And part of the analysis process is going through all of them. However, for the sake of the video, I've keyed in on this one because that one is the one that is most beneficial for us to take a look at. And we already know that it's part of the Metasploit framework, which I'm familiar with from red teaming. However, the next cool tool that we want to take a look at in order to perform some of these further analysis that's outside of just looking at this from the memory is a tool called floss. So if you go to Flare floss, you can Google that as well. Just type in Flare floss and it'll take you to exactly the GitHub page. So right here, you go to releases and you can download it. And I downloaded the Windows portion of it. And this is made by our friends over at Mandiant, FireEye, and it's an obfuscated string solver. So it works exactly like strings.exe. If y'all have done some static malware analysis, that tool takes strings.exe and this floss takes it to a whole nother level. So let's do some flossing. So we're going to go back to our forensics tool folder, and we want to go to floss. So floss is right there. Let's CD now, and then floss. Floss.exe. And the syntax is kind of similar. Floss, pass to malware binary, and it'll output it for you. So those dumps were in the volatility folder, so we're gonna go floss.exe, and it's this BFT100 dump. That file. So this is the command that we're going to run. And you can output it as well to a text file. And you can run it. And there it goes. So it runs, gives you all these strings, all the strings that are there that are useful. And at the bottom here, look at that. There's IP. There's another malicious activity there that's calling out. So that's connection going outwards. And here's the output, like looking at it, right? There's a large file, but you can also go through and see that most of it's gibberish. Scrolling down to the bottom, right, there is that con outs, TCP malicious IP there. Porting over 443. And this is the IP from Thailand. So this is what we in the game would call a command and control address, or C2, as this is the IP that's being used by what I'm going to call the interpreter payload at this point to call back to the attackers. And this is awesome. So there you go. We've already dug it deep into we've gone and done a few things here already. And we've gone and done our memory analysis on that domain controller. We've identified that core updater. We have a C2 address here. So that's a network indicator of compromise, an IOC. And I just want to give another massive and huge shout out to our friend James. Not me, but James over at DFIR Madness. Because this is quality, and I'm not doing this justice by simply running the tools and showing you all the data here. As you can already tell, there's so much here that you can literally build a genuine timeline just like you would for a real case. In fact, again, if you haven't already, y'all should be building a timeline based on your analysis efforts, as it's good practice for when you're in the industry. And I will say almost all of my analysis efforts on the job result in me producing a timeline. So I've been taking notes and marking timestamps. And I hope you are too, because you need that timeline to be able to explain what happened, when it happened, and then you'll have the artifacts to support it. But now we have our IOCs for our attacker boy, which is that IP, as well as the malicious executable and injected code. So this IP right here, we're taking note. We're going to mark that down. Let's see. Yeah, so let's put that there. Okay, Google. This IP address is malicious. We can answer that question here. So I have adversary involved in other attacks around the time of the attack. So I think that would be a yes, because there is two. There's a couple of things going on there. There's the core updater, and then there's also that spool SV. So there's core updater.exe, but there's also injected interpreter in spool sv.exe. Did someone move it? So core updater.exe maybe it got moved. What were the capabilities of that? So that's interpreter. So again, I'm not really doing justice to the whole case, but that's because I did do this last year in a more serious fashion. So right now I'm just going over it all and having a little fun here with y'all. But malicious IP involved. Yeet. And so right off the bat, did the attacker access any other systems? Yes. Spoiler: they also accessed the desktop. So y'all can go and perform your memory forensics on that desktop image as well. I'm not going to, simply for the fact that the video is already getting pretty long as it is here. But now let's just do the cleanup, toss in those. And at this point, right, so we have a IP address that we are going to be taking a gander at. So this IP right here is going to be classified as a network IOC. And we're going to be taking a look at this because the next artifact that we're going to be taking a look at is going to be the PCAP file. So we're going to be able to go and look for this IP in that PCAP and hopefully go further and see what we can look at and the network forensics portion of this series and doing analysis there. So you can do analysis on the desktop as well because we have that memory too, but I'm not going to do that in video, as I said, as what you're going to be doing is basically confirming the same IOCs we found here are present on that desktop as well. So we answered some of those questions there, but now that we've gone and taken a look at the disk images and the memory here, the last thing left for us to look at is the PCAP, which is going to lead us to network forensics, and we already have a great starting point, which is this malicious IP address. So I'll see you all in the next video, and we'll take a look at that PCAP and do some fun network forensics with Wireshark. So if you don't already have Wireshark installed, you can Google and install that tool. But that's it for this video. I hope you found it valuable. If you did, please leave a thumbs up, comment, and subscribe for more content from your boy Jester James. Thanks for watching, and I'll catch y'all in the next video. And also, if you'd like, I can go and recap through all the analysis that we've been doing and kind of put it all together and then slowly start to show y'all how you could go and build things like a timeline and have those procedures put in place. However, it is pretty straightforward. You're matching things up with the timestamps, and it's exactly what it sounds like, building a timeline based off of what you're gathering here. But the next video, we're going to be taking a look at that PCAP file in Wireshark, and we'll be looking for some more IOCs there and looking for that IP and performing some network forensics. So that's it for this video. Thanks for watching. I'll catch y'all later.